Alright, so when we're talking about equations, there's a couple of terms that are going to come to mind that are either new to you or maybe you've remembered them from a prior course. But one of those terms that we're going to talk about today is coefficients. A coefficient is the number that is in front of a variable. Now, one of the most important things to realize is that sometimes these numbers are very much in front of your face, and sometimes they're a little bit harder to find. So one thing that's important to know is that every variable has a coefficient, and watch out for your signs, particularly negative signs, because negative signs are included in a coefficient, right? And when you look at one like this, it's very easy to see. All right, so here's your variable, and the coefficient is going to be the number that's in front of it, but it also includes the sign. And sometimes that's very obvious in that case, but when you're talking about a longer expression or equation, it's very easy to kind of lose sight of that. But just remind yourself that the negative sign is part of the coefficient. And that's going to be something that comes back over and over and over again over the course of the year, especially as we learn more complex equations and math concepts. So the negative sign is part of the coefficient. So let's look at these examples here. I have three expressions here, and we're just going to look at each one and pick out the coefficient for each variable that you see. All right, so I see here that we have 3x minus 4y plus z. So let's just go right into it. The coefficient for x is going to be the number that's in front of x, so it's 3. The coefficient that's for y is actually going to be negative 4. It is the 4, but it's also the minus sign that's there as well. So one thing that I always hear is it a minus sign or is it a negative? And the answer is it's both. They're the same thing. It just depends on the context that you're saying it. So when I'm looking at this entire expression, what I see is, if I were to read it, is 3x minus 4y plus z. But if I cover up the other terms and I'm just looking at that middle term, then that's a negative 4. So it really depends if we're looking at it as its own thing or if it's in the beginning of an expression. But if it's in the middle, it's a minus sign. So it's the same thing, just don't get too caught up in the name of it. So now for z, now this is what I'm talking about if it's not clear. There is a number here, but it's a 1, and it's not traditionally written, but I'll put it there right now so that you can see it. So the coefficient for z is 1, and it kind of makes sense if you think about it, because there's just one z that's over there, so it's implied that there's only one, right? Now 3x's is the coefficient there. They have to explain that to you, but when it's just a letter that's just by itself, just assume that the number is 1, or negative 1, which we'll see later. But right now that's a plus, so I know it's a positive 1. Over here you're going to get the coefficient for x is going to be negative 2, and the coefficient for y is going to be 1/4, or 1 over 4. Positive, because there's a plus there, and negative, obviously, because there's a negative in front of that 2. The signs will always be part of it, and they'll always be on the left. So that negative is on the left of 2, so negative 2, positive 1/4. And then this one for z. Now z is part of a fraction, but in front of z, directly in front of z, there's nothing there. So we should always assume that that's a 1. Now, it would seem safe to say that the coefficient for z is 1, but since z is part of this entire equation, it's actually going to be 1 over 4. So this is another way to write a fourth. So they could put the 1/4 in front of your variable, or they can put your variable over 4. They're both saying the same thing, 1/4 and 1/4. Now over here is very similar to what we did before. The coefficient for 5x is just 5, and the coefficient for y, now for y, it's part of this larger fraction, so the coefficient for y is going to be 2/3, positive 2/3. And z has no coefficient that's written down, so I'm going to assume that it's a 1, and we'll just take the sign of the number in front of it, so it's going to be a negative 1. And this is just something that keep in mind for future references, future examples and problems. It's just going to be something that you just need to kind of adopt into your mindset. Now, when it comes to the word terms, a term is a combination of a variable, no matter what the variable is, right? Typically it's x, but it could be any variable, and its coefficient. So I'm going to use a marker here, 2 markers in fact, to give you an example. I'm actually going to reuse an example that we just used. So let's just say that for right now, our variables, or coefficients, sorry, let's do coefficients, will be red, and our variables will be green. I'm going to take the first example that we did together, this 3x minus 4y plus 1z. So we just talked about coefficients, and we already have known about variables, and now we're going to describe the idea of a term. So any equation or math expression can have multiple terms. It could have 2, 3, 4, 5, a bunch, right? But knowing what a term is helps to think of it. It's like a cluster, if you will, of numbers and variables, right? And they're often separated by these operation symbols. But let's just use this example. 3x minus 4y plus 1z. Alright, so the coefficient will be 3, but if it's 3x, then the variable will be in green. Minus 4y. Now I'm going to use the marker to include the negative with the number itself, because they do go together. And then plus 1z. And I'm going to write 1z here. The 1 is optional, remember. And it's better if you kind of get used to not writing it, because you won't really see it, going forward. But for right now, we wrote it all out. 3x minus 4y plus 1z. So this is a 3-termed expression. So this has 3 terms. And we call anything that has 3 terms a trinomial. And while that name we'll come back to later on in the year when we deal with specific ones like quadratics, that just means 3. Tri, like tricycle, means 3. So this is a 3-term. Some people call it a polynomial, poly meaning more than 1. So there is 3 terms, so that would qualify as well. So this is a trinomial or a polynomial. Poly meaning more than 1. More than 1 term. Tri means 3. Alright, so when you look at this, in colors it certainly helps, but obviously this would be written in black on any other worksheet that you would have, but it helps to organize it right now. So the coefficient and the term and the variable here will make this is our first term. Now our second term actually begins with the negative sign or the minus sign. In this case, I'm going to think of it as a negative because I'm only looking at this. I don't see the other stuff. That is a negative 4y. That is going to be your second term. And then the plus 1z will be your third term. So a 3-termed expression. And so when you start to look at these problems, it certainly helps to kind of almost have a tunnel vision, so that if you're looking at just your x variable, that you can kind of eliminate those from your mind and just look at it as a 3x. Or if it's just y's, it's negative 4y. Or if it's z, it's just 1z, or positive z. Okay, so now let's take this idea and let's just move forward from it, right? Because we need to have that as our foundation for us to do the distributive property. Now the distributive property, we've already talked about it, at least what it is, but now we're actually going to use it because as far as algebra goes, it's one of the most important things as far as solving. So each term, now that we know what a term is, each term inside the parentheses is multiplied by the term on the outside. Now we say that a term is a number and its variable, but if it doesn't have a variable, it still qualifies as a term. So right here, this is going to be our distributive term. And by distribute, we are going to multiply each term on the inside by negative 2. Now, whenever I see one of these problems, I try to remind myself to be careful, because you need to know where the parentheses or your grouping terms will begin and end. And so when you distribute, you're never going to shoot across the parentheses. You're going to just go to each term on the inside. And since this 5 is not part of the inside, you're not going to multiply to that 5. But when you multiply, you're just going to multiply the numbers together. This term with the coefficient from this term. Even though there's an x there, I'm really only working with these numbers right now. So negative 2 times 4 will be negative 8, and since this had an x, this needs to be x as well. Negative 2, and this is the tricky part where you have to start looking at terms as a whole. This is a negative 12y. So I'm circling it so that we can emphasize that sign. We include it in this process. So a negative times a negative makes a positive, and then 2 times 12 is 24, and we just follow up with a variable because we can't lose that. And then we'll finish off with the plus 5. And you're done. You can't do anything else here, and that's all I asked is to distribute, and that's basically how you do it. So we're going to practice this now, right? If you want to pause it, you can. If you want to give it a shot and then see how you did, that's totally fine. You should pause it right here. But if not, let's just move on. Here's your distributive term. It's right outside your parentheses, and it always will be outside your parentheses. That's a key indicator that you need to distribute. So right now, I am going to distribute 3 to 11x. So it's 3 times 11. That's 33x. And then I'm going to distribute 3 to the 4y. Now remember, that is a positive 4. So that's going to stay positive. And 3 times 4 is 12. So it's 12y. And then 3 towards this positive 2. Positive times positive 2 is going to stay positive, so 3 times 2 is 6, and you're done. That one's pretty straightforward, but it's actually B, and we'll see C, that are a little bit more concerning. The one thing you don't want to do is you don't want to subtract, and sometimes that happens. People think that that's the right move to do, but you can't get caught up in that, because what you actually have is you have these grouping terms, and you have a number on the outside, and you need to distribute. Now when I distribute it, I'm distributing it as a negative 2. Now we had a negative 2 up front, and it seemed very easy that that was negative 2 because there was nothing over here in front of it, on the left of it. But over here we do have a number on the left of it. It's a 5. So in order to avoid any confusion and so you don't lose it later on in the problem, the first thing I do before I actually distribute is I'm going to take that 5 and I'm going to write it down, because it is part of the problem and you can't forget it. But now I'm going to go to distributing. Now this is a negative 2 times this x. There's no number there, but you should remember that that's a 1. So it's like a negative 2 times a positive 1. A negative times a positive is a negative. 2 times 1 is 2, and it has an x, so you write your x. And now you move on to the next term. Now remember, I'm going to circle it, and it gets a little crowded when you do all this circling, but it certainly helps to focus on those terms, and that's the whole point right now, is just to focus on them. A negative times a negative is a positive. 2 times 5 is 10, and that's y. And now we're done with that one. So just be careful of your signs, like I said. Sometimes you have a grouping term, and there's no number out there, but there's a negative. And if that's the case, you can consider it, just like before, as a negative 1. It's like secretly in there. And so when you distribute, you're going to treat this like a negative 1, and you're going to multiply each of these by negative 1. Well, a negative times a positive 3x is going to make that negative 3x, and a negative times a positive 6y will make that a negative 6y. So another way that I look at it is that it's almost like it reverses the signs of the terms that came, or the terms that were inside. It reverses all the signs. So if that negative comes before the parentheses and there's nothing else, no number with it, just consider it that way if you want to think of a shortcut. Just take whatever's on the inside and just change the signs. It was a positive 3x and now it's negative. It was a positive 6y and now it's a negative 6y. So sometimes you don't have to go through the entire process of like distributing like that on paper. You can kind of just imagine it in your mind. I'm okay with you mental mathing that. But all of this leads up to combining like terms, something that either you did last year or now you're going to be introduced to it. I like to call combining like terms for short. I call it CLT. And it's pretty basically what it sounds. You're just combining things grouping things together that are similar. So a like term is a term with the same variable that has the same exponents. And I'll explain that in a minute. You can combine like terms by adding the coefficients. Now remember, the coefficient is the number that's in front of the variable, right? So if we see two things that have an x, we can take their coefficients and add them up and combine them together. So let's actually look at a problem where we have to do a little bit of work before we can combine like terms. So anytime you see a parentheses, you should probably think, well, it's either going to be order of operations and you do grouping terms, or it's going to be the distributive property. If these were all just numbers and there were no letters, no variables at all in this problem, I would just handle this inside math. But the problem is, in algebra, there's nothing to be done in here. Everything that can be done to it has been done. So the only thing that's left is to distribute. And at the very least, it'll allow us to get rid of these grouping terms, which is what my goal really is. So I'm going to multiply each term on the inside of the parentheses by this distributive term on the outside, this 3. So 3 times 5x squared, now don't be fooled by that, that's just what it is, it's just a label, it's a variable with its exponent. I'm more concerned about the numbers, the coefficient. So 3 times 5, all positive, would stay as 15, x squared. 3 times a negative 1, 3 times a negative is a negative, so it would be minus 3x. And 3 times a positive 4, 3 times 4 is positive 12y. And then you're going to just fill in this information from before. Don't lose it, it's important. From here on out, you're going to combine anything that has the same variable, and those variables need to have the same exponents. So, you always start with the one that has the highest exponent, and I see a 2. So right now I see 15x squared. There are no other x squareds in here. I'm looking and I don't see any, so that means that this is its own unique term, and it's already simplified, so I'm just going to write it down. And as I do these, I like to scratch them out so that I don't miss one, or that I at least know that I've accounted for everything. The next one that I'm going to do is x. And if you're wondering what kind of order does it go in, it goes from the highest exponent to the lowest exponent to having no variables at all. And I typically go alphabetically. So I'm going to stick with x's now. I have a negative 3x and a positive 2x. So like a negative 3 plus 2 would be minus 1 or negative x. And then we have our y's, which is a positive 12y and a negative 8y, and it's like 12 minus 8, so that's going to be a positive 4y. And we have combined like terms. These have combined down here, and these have combined to make 4y. And you're done. That's it. That's the best that you can do. You can't solve anything because there's no equal sign, and you can't plug anything in because you don't actually know what the values are. And then we'll just move on to this one. So now as you distribute, just be careful of the sign that you see, right, and include it in your distributive term. If it's there, no matter what's before this, if that's a negative in front of this number, then you need to kind of think of them as traveling together. So we're going to distribute negative 2 times a positive 1x. A negative times a positive is a negative, negative 2x. Negative 2 times negative 2 times negative 4y. A negative times a negative is a positive, so this will be 8y. And then we still have our plus 3x and our minus y. And then from here we'll combine. I have two x terms, a negative 2x and 3x. That makes 1x, or x. And then I have 8y minus 1y. 8 minus 1 is 7 plus 7y. And you're done. Let's try this one. A little bit more challenging perhaps. It looks a little intimidating, but the first step is going to be to get rid of these parentheses. So we are going to once again distribute. So 3 times a positive 2 is 6, and that's an x squared. 3 times a negative 6y, and I'm really focused on these numbers right now. 3 times negative 6, a positive times a negative is a negative. 3 times 6 is 18y. And then we have 3 times a positive times a positive is positive, so 3 times 3 is 9, and it's xy. Xy itself is considered its own unique thing. There's x squared, there's y, there's xy. So just keep that in mind. And then the rest of this will be brought down. And I'm going to start with the highest exponent, so it's the squared. So 6x squared minus 1x squared, 6 minus 1 is 5x squared. And we can just scratch these out because we've used them. Now I'll move on to y's from here. Minus 18y, or a negative 18y plus 1y is negative 18 plus 1 is minus 17y. And then we'll do our little hybrid variables, if you will. This is a positive 9xy, and this is a negative 2xy, so it's like 9 minus 2, which is 7xy, and there's nothing else that you can do. You can't combine any of these. Even though this has both x's and y's, none of these have both an x and y. You know, this is an x squared, and that's a y. So they're all different. They're all unique, so you're done. You've combined everything that's similar. And that's it.